everyone, welcome to this lecture video. Today we are going to learn about one of the sorting algorithms, bubble sort. In bubble sort we swap the adjacent elements continuously if they are in wrong order. First of all, we traverse from left to right, find the largest element and move it to the last position of unsorted portion, and we keep on doing this until we have successfully sorted all the elements of an array. Let me show you with an example what I mean by this. Let's suppose we have an array 6 0 5 4 and we want to sort it in ascending order using bubble sort. Our goal is to traverse from left to right, find the largest element and move it to the last position of an unsorted portion of an array. This whole array is unsorted portion in the beginning, and we have to move the largest element to the last position. How can we find the largest element? By comparing the adjacent elements and seeing if they are in wrong order. If they are in wrong order, we'll swap these two elements. 6, 0 are adjacent elements, and yes, they are in wrong order. They are not in ascending order, so we will swap these two elements and the array will become 0, 6, 5, 4. And now again we'll compare two adjacent elements 6, 5. They are again in wrong order. We'll swap these two elements and the resulting array will be 0, 5, 6, 4. Again we'll compare two elements 6, 4. Yes, they are in wrong order. We'll again swap these two elements and the resulting array will be 0, 5, 4, 6. So this is our array, and we have successfully sorted the last element, moved the largest element to the last position of an array. Now we'll continue to the next step, in which we will try to find the largest element in unsorted portion 054, and move it to the last position of an unsorted portion. So we'll again perform the same thing. Compare the two adjacent elements 0, 5. See if they are in wrong order. No, they are not in wrong order, so we will just write it as it is. Now again we'll compare the adjacent elements 5, 4. See if they are in wrong order. Yes, they are in wrong order, and we will swap these two elements, and after swapping these two elements the array will become 0, 4, 5, 6. We swapped these two elements, and now you will realize this is supposed to be unsorted portion and this is supposed to be sorted portion of an array. Now here is our array. In step 3 we have this array 0, 4, 5, 6, and now we want to sort the unsorted portion 0, 4. How can we sort it? We'll just perform the same operation again. Compare the two elements, see if they are in wrong order. If they are in wrong order, we'll swap the two elements, but they are already in sorted order, so we don't need to swap them. And there is no element after 4, so we don't need to compare 4 with anything. So we have successfully completed step 3. And you would have noticed we didn't perform any swap operation, so which means we can break out of the loop, because if we don't perform any swap operation, meaning every element is in correct order, meaning we have already sorted the array and we don't need to perform any further operation, and we can just save our time by breaking from the loop. Now let me show you in Python how we can write an algorithm for this. Let's suppose we have an array 5, 9, 4, 3, 1 and want to sort it using bubble sort. First let me store the length of array in variable n, and this n should depict how many steps we need to perform in worst case scenario, and we will use for loop for that. And we will use another for loop for j in range 0 comma I minus 1 n minus I minus 1, and this for loop should be to compare the adjacent elements to find the largest element in unsorted portion and move it to the last position of an unsorted portion. And why am I using n minus I? I am using n minus I because I want to go only until the unsorted portion. I don't want to I don't want to move, I don't want to compare the sorted portion. The portion we have already sorted. I just want to ignore that portion. And we can do that by using n minus I. And why I have used minus 1? It's because we don't want to compare the last element. We don't want to traverse to the last element, because if we are at last element there is no other element to compare with the last element, so we will just skip that part and just move until the second last element of the unsorted portion of an array. It will be more clear when I write it in code. So what we can do is, here we will compare the adjacent elements. If arrj is greater than arrj plus 1, meaning they are in incorrect order, we'll swap these two elements. And once we have swapped these two elements, we'll keep on doing it until the end, and this will automatically move the largest element to the end of the unsorted portion of an array and then move on to the next step. But as I told you, if we don't perform any swap operation in any step, then we just need to break out of it, because it will be waste of time to keep on doing this, since if there is no swap operation performed, meaning they are all in correct order. So how can we do that? We will just use a variable swapped is equal to false, and every time we swap anything, we'll just change it to true, and at the end of every step we will check the swapped variable value. If swapped is equal to false, meaning we didn't perform any swap operation, meaning everything is in correct order, we'll just break. It will break out of the for loop and save us time. Let's print out the array. Now I will just print out the array and see if we correctly wrote the algorithm for bubble sort. Let's run this now. And yes, it successfully sorted our array in ascending order using bubble sort. Now let's talk about time complexity and space complexity. In this, bubble sort's time complexity is O of big time complexity is equal to big O of n square. Why big O of n square? Because we are using nested loops. We are comparing each element with the other element.